Hello folks, right, well, doesn't get better than this. We've got a boxed Harrier CB-HQ from Trucking and Farming. I don't think I've ever seen one in a box before. These were either £129.99 or £159.99, I just can't remember. At the time, I will have seen them at both prices. I don't know whether it's newish, but it'll be getting the power supply rebuilt, whatever we discover. So we've got factory original mic, a mains plug. Oh yeah, I think we've got the mains plug to put on, but we'll come right to that right at the end. So these, one of the queries, these are a double insulated product in a metal case. You'd expect there to be an earth in the lead, but there isn't because it's double insulated. And it's double insulated because it uses a shrouded mains transformer, which of course has a proper primary and secondary. So this uses the Cybernet 134 chassis, and like the Harrier CB and the CB-HQ uses therefore the same chassis as the Midland 76900 base station that we use for the tests. And of course we own 3 of these, and we used to use these for the on-the-air tests. The 76900 has no advantage whatsoever. It doesn't do anything better, it just has more knobs. That's what you paid your extra 200 quid for. So this has a 12 volt capability as well, which is always handy, and was the disadvantage of the realistic TRC 3000, which I used for many years until we discovered we got a lot of power outages here. So this is pretty immaculate, and we're going to start by taking all the screws out of it because it's all going to have to be done. I think we need an extra pot to put screws in, which I will get. I'll tell you what, we'll run through the tests as soon as the thing is, shall I put the mains plug on now? No, we're not going to run it on its own power supply, that would be silly. So we need to get inside, disconnect the... No I don't, we can run it on 12 volts, can't I? Yeah. Think. Run it on 12 volts, or 13.8, and we won't be running the power supply up. I won't be tempted to put the mains plug on until such time as I rebuild the power supply. At 40 odd years old, like it or not, it's going to need those capacitors changing. I've done tests, you know. I had a I've done it with the HMV stereo masters we work on. I remember we bought one specifically, but I think it was 1971 model. I simply plugged it in, and after 20 minutes the capacitors blew up. So that's what happens. Right, I'll go and get a pot to put these screws in. So I've got about 40 minutes. It's Friday, and about 11 o'clock in the morning. Put those to one side. I'll try and keep... No, we'll take that off. It's only going to fall off, isn't it? It's not often you can see there isn't much dust in this. I might end up putting it through the dishwasher nevertheless. Right, we want a job sheet. So it's box 9, trucking and farming. This is 6th of February 2026, Harrier CB-HQ. And it's 111000882. I remember getting one of these in my shop in Yorkshire about January 1982, and the lad who'd been generously given this as a Christmas gift had twiddled and broken all the, I've got to put this in inverted commas, all the horseshoes inside. Doesn't change, does it? I wonder if he's still got it after I repaired it 44 years later. Right. Yeah, we'll go in through the power socket on the back. And we'll use our power lead. Oh, I better plug the test equipment into the back of the radio. So it'd be nice to get the radio actually done in this session, and then we'll just have the power supply to rebuild. No, it's not new, is it? It's got marks on it. But it's pretty immaculate for 40 odd years old. 13.8 volts. I think we've got to switch these. Do we have to switch these? No. I think the on and, does the on and off switch do? Yep, the on and off switch. And yes, that is the right meter brightness. The on and off switch is on just on the low voltage, I think, on these. Or is it? Got one pole there. No, it hasn't. It's it does mains. It's single pole mains, single pole 12 volts. Because a lot of base stations, all those Uniden ones, they only switch to 12 volts, and the power supply remains on whilst ever the radio's plugged in, which isn't ideal. So you've got these, the Midland 76900 and the York 869 base stations, which all use the Cybernet 134 chassis. I'll just go and get my standard Cybernet mic. Do these have PA? Nope. Plug our test equipment in. It's not very visual. I can't really push it upwards, or it's going to be on the connectors. Put picture in picture on. The test gear's been on for a few hours. So let's see. Oh, there we're going to go, aren't we? Because I've got the earth on. 79107, that's all I wanted. 2779107. Let's look at power. We're on the 3-watt scale. It's not quite doing 3 watts. 2.75. Just checking we're at 13.8 volts. drawing 900 milliamps, and on low power it's doing 50 milliwatts. It's a special 10.1 edition. Back to high power and channel 40. 2.6 watts, and channel 1 2.85 watts. Deviation, if we can manage to look at it over the feedback. Not sure we're going to be able to do that. No. I'll do all the other things. Right, receive 27.79107 we want. Just turn the volume down a fraction. Try and get that as close as possible. That's pretty close to 27.79107. And we'll look at the SINAD meter. At the moment we've got, on 100 microvolts, it's reading just a bit short of 9. It's 300 microvolts. We'll just go back into transmit and I'll look at the meter. It's reading bang on the 4 for its 2.75 watts output. Meter lamp's fine. It doesn't have PA. The potentiometers are all okay, apart from, I think, low power preset. Dirty. Let's check the other switches. Yeah, they're okay. Sockets all work. I'm not testing the headphone socket. Okay, SINAD. So let's put it down to 1. Oh, it's very, very good. 0.22 microvolts. .2 microvolts. Yeah, we can get 4 watts out of this as well. It'll be fantastic. 0.37. That's exceptionally good. Squelch. Squelch to full. Let's show you the attenuator. I want it to be 100 microvolts, but there's no hard and fast rule on that. It's 30. It's coming in at 26, which is a bit wishy-washy. Turn squelch to minimum. Put the signal generator to standby at 0.3 of a microvolt. Set the squelch on the radio for threshold. Put the signal generator back on. Straight in at 0.3 just. I'm going to put 3.5, it's struggling. Internal speakers working. Right, we'll get it opened up. Turn it off for now. That's for when I drop parts inside it. Don't ever lose those screws at the side. I wish I could know how to order them. It's not the fact they're M4. It's the fact that they've got this recessed bit. got an M4 screw with this plain bit, which is about 6mm. I mean, yeah, you could just jolly well put a long M4 screw in there, which is about probably 15mm long. Nobody would be the wiser, but it just wouldn't. I don't know. I don't think it'd make any difference. That might be a thing for me to do, because we do have M4s in stock for putting in Uniden base stations, but no end of these sets you buy have got these screws missing. That's what I'll do. I'll order some long M4s. You're never going to get them with as big a head. So you're all witness to the fact it's got all the 4 screws in this one. No, that's it. So as we suspected, it's a very low hour set. I will now disconnect the external speaker so we haven't got the feedback problem. Switch the radio back on, turn the volume down. We'll just do our deviation casual test on here. Wrong meter, that's the one. Wow, it looks to be 2.2, which if it is spot on. Switch the test set behind me on. Ready. We'll start by doing the VCO. We're selecting channel 40 on the radio. Just get our earth wire to make it easier. Whatever this capacitor is, we want it to be 3300. It's 2200, so we do need to upgrade that to 3300. I'm not saying these hum, but it's inadequate. Considering these aren't asked to do more than 1.5 amps ever, you know, it's nice hefty transformer. I bet it's 3 amp capable. You know, so the whole idea is the power supply is running cooler than it would do if it was being thrashed. So we'll be changing all the capacitors and we'll be upgrading that to 3300. I'm also going to check carefully that this nylon mounting screw is at the correct tension. Always be careful with those, because obviously they're easy to snap with them being nylon. I'm just able to move it a tiny bit. When we get the power supply on this. Right, test point 1 is the far side of resistor 4, and on channel 40 we should have 4 volts on transmit and 4 volts on receive. We've got 5 volts on receive, and we've got 5.2 on transmit, which is bad news. So it's 5 plus 5.2. I'm going to start by moving receive, because sometimes transmit comes into line because they are interactive. I think we've got glare on that. I don't think you can. I've got so many fluorescent lights in the ceiling. So which way is it going to be? Let's try it left. No, that's worse. I mean, moving this from 5 to 4 volts will probably be a quarter of a turn. So let's see at 3.9 something. Let's go into transmit. It's 3.5. So tell you what we're going to do. We'll put this to something like 4.1. How about that? See where transmit is now. And now we'll adjust transmit. I'll use the other trimming tool. I've just been using the 1.5mm one. And if I can find the 2mm one. Yeah, right. Wasn't that big an ask, was it? I can see it's on the floor. Ceramic tool on ceramic floor. Waiting to be broken. I'm going to put this on low power so we're not heating the transmitter up. So go into transmit. Go back to receive. Go back into transmit. Fine. You sometimes have to go backwards and forwards. Oh, let's do the checksum, which is channel 1. Select channel 1. And it needs to be between 1.8 and 2.3, 2.4, something like that. If it was wildly out, I'd get the service manual out. 2.1, and on transmit, 2.17, so it works out. I've seen an Amstrad, that's a Cybernet 002 chassis. That's the only thing Amstrad about Amstrad radios is the name on the front, unless you get a fake one. Then it's a fake Strad, isn't it? But I've seen them with a minus number on the checksum. Okay, so we've done that. Go back to 1.5mm tool, and we're going to do, I'll take that earth off now, we'll do these three, and we want the centre of the peak, not just the peak, so we're detuning them to retune them. So we're on the 3 watt scale. I'll go back to full power. I unkey in between so it cools down a little tiny bit. That one's correct. Those two are right. That was a quarter of a turn out. Right, we'll now do the PA with the Velleman tools, and we'll be using the ones which my friend Gareth at Leeds has reproduced for us, because they're actually stronger. So the blue one says blue on it, and we want to temporarily put these 3 to maximum, because to balance the transmitter we need to be able to achieve 4.4 watts. I'm going to put the power on the test set to the 30 watt scale, so now we're looking at here as 4 watts. If you wonder why the test set has 30 watt scale, it's because business radios in the UK are 25 watts maximum, so that would be, you know, what you'd expect, because you're going to tune them slightly above to get them right. And with it being all business radio equipment, that's what we're doing. That's now maximum. This now needs to be maximum. Now the fact that I've been able to alter that means it's been fiddled with in the past. I'll tell you what, we can't achieve 4.4 watts. What we're going to do, I'm going to up the power supply to 14.4 volts as a temporary measure in the hope of being able to get 4.4 watts. It's just on the cusp of 4, and so that's fine, but it's got to be balanced. Can't leave it like it is. So I'll just pop the power supply to 14.4. The never exceed is 15. We'll just do this again. Yeah, I've got 4.6. Okay, so we're now going to turn the yellow one clockwise to achieve 4.4 watts. And we're going to turn the green one anti-clockwise I've set it to about 4.1. So I'm now going to drop the power supply back to 13.8. And we're doing about 3.8 watts, which is actually what the manual says. Just check it on, check the balance. 3.6, channel 40, 3.8. And I'm going to come back to this when I've rebuilt the power supply. So we're not going to write down these figures. What I can do is I will adjust, that's banging across, as you'll expect, and we'll do low power. That's going to be a dirty preset. Waggle that around. Want it on low power, don't I? There we go. So that's now corrected. So we'll do all the figures after I've had lunch and rebuilt the power supply. I'm saying this because there's going to be a different voltage drop on the 2 meters of lead I've got to my bench power supply, which is a 3 amp maximum capability, and when we put this back on its own power supply, 13.8 volts may give a higher output than what it does from the bench power supply with all that cable, so we'll see. Deviation, we're not ready to do that yet, but I'm going to put this to center position, ready for when we do. Let's get the radio on frequency. Use a 2mm trimmer. I mean, now the radio's cooled down, it's just smidging away. It's like 3.95 watts. Everywhere but 26, that'll do. (27.79126). Okay, so we'll do the receiver. I'll reset the signal generator to be spot on the correct frequency. Good. Right, let's put 100 microvolts on and we'll have a look at the oscilloscope. We'll also plug our test gear back in. we go, 100 microvolts, put camera 3 on. Check the detector. All we've got to do is find the other trimming tool. I'll use the RS one, seeing as the other one's hiding. So we're looking for maximum recovered audio. Oh wow, that was a bit out. So we might have had a false better sensitivity because of that being out. That can happen. In view of that, I'm going to do the IF first. We'll be looking at the SINAD meter, which is about 20 dB, so it's hard to see the differences at this level. But I'm looking at the meter on the front, I'm looking at the oscilloscope and the SINAD meter, kind of all at the same time. Marginally out. You get the bigger filter. You don't, that's the smaller filter. How come? You get the extra receive stage. I've not noticed that before. You get the 2-pole filter instead of the 4-pole one. How bizarre. That was out as well. I'll drop my signal. That was spot on. So with the 1.5mm tool, we'll do the front end and drop the signal to about 4 dB. This is the extra one you get on the base stations. If I can get the tool in. That was spot on. That was spot on. Absolute minute fraction on there. So be ready for this to be worse. The detector was so far out. No, it's not. 0.2. I'll just see whether we've got anything better than 0.2. I doubt it. I'm between scales as ever. But yeah, it's the same. For 20 dB, 0.32. Right, I'll set the S meter. To be honest, that's come right. That didn't need readjusting. Let's do squelch. Show you the attenuator. Put squelch to full. And again, I want it to be 100 microvolts. It's not, so I need to adjust the preset. We'll use the 2mm tool till that squelch comes in, and then we'll see whether it opens at 100 microvolts. It does. Right, at the other end of the spectrum, turn the signal generator to standby. Set squelch on the radio. Put the signal generator back on with the signal generator parked at 0.3 of a microvolt. Not quite in. 0.56. So it's a more realistic squelch range. 0.56 microvolts to to 100 microvolts. The RF meter now is correct at 100 microvolts. So, what am I doing? We haven't done that yet, so I'll falsely put that down. That is now correct. So I'm going to leave the radio on. Just check that the S meter still reads, because you can end up altering the squelch, and there's a bit of interactiveness between. It had moved a fraction. Right, so I'll go and have lunch, and when we come back, I can turn the oscilloscope off and the SINAD meter off. When I come back, I will see what the deviation is on the test set behind me. I'll plug it in ready. See you in half an hour. Right, so I've disconnected the radio from the power. I'll just unplug the mic so that it's not dangling. And we'll start by taking this capacitor out and replacing it with this one from RS 7441253. No wonder they know how to charge with packaging like that. So 3300, 63 volts, 105 degree rated. And the reason being, we want it to be the same kind of diameter. I might still have to end up drilling holes, but we buy these, I think it's the Harvard 407 base station. That's why we actually have these, and that's what the exact size is for, so that it fits in the P clips. But we obviously buy the same one and fit them in everything where we feel that it's necessary. So I'll end up probably, I think this got multi holes, but we still may end up drilling a hole for it because it's wider. We've got 2200 cans, but I'm upgrading them these days to 3300. We've also got ordinary quality capacitors rather than these which are supposed to be for power supplies. They've got better ripple rating. Did I say that right? So there's multiple holes. I'll try and, I hope they haven't bent the pins under. That's one of the things they can do. I think the best thing to do is to try and just remove it. I've got to overcome the glue as well as the soldering. Now I want to be careful. So as I've brought that out, the negative side is towards the radio board. So I'm just going to unsolder all the available pinholes which are in the board. It's not wanting to unsolder that one, is it? In the hope we don't have to drill any extras. While we're at it, we'll take that capacitor out. And what way's that come? These boards aren't labelled. This is positive to the radio. And what do we want? 100 microfarads at 25 volts. I'll go and get one, and we'll do that immediately before we forget. Right, I've done that. So we've got the positive to the right. And on this one, I've already forgotten what I said. But because we've got the glue to help us, we can see how it came out. And it's negative. So hopefully look at that, it does fit in holes that are already there. That kind of tells you they'd planned for a possible bigger one. And what we'll now do is the isopropyl alcohol, because they don't seem to have cleaned this subboard. That's better. So I'll give that 20 minutes to dry, and I'll get a mains plug wired on it. And where's the mains lead? It is there. And there's his plug. Let's just make sure we've got a 3 amp fuse in that. So we'll need to swap his fuse from a 13 amp to a 3. Let's put the screw inside the radio. We need these to be shorter than what they are presented as. It's normal to have no play in the live and a bit of play in the neutral, so if it gets pulled out, the live is pulled out first. Make sure the screw for the earth is actually tightly in, otherwise it could migrate outwards. So what I'm going to do now, we'll put the cord grip in so we can judge the neutral wire pretty well. These are actually nice plugs. They've got a bit of a strain relief here, which is not something you see. They're probably specially available only to people involved in farming and trucking. So I'm going to keep this its full length. I'll just cut a fraction off that. Wrong screwdriver. So the idea here is if the cord grip failed, the live would be yanked out and the neutral wouldn't. So we'll leave it there. I have to go to the chapel actually, where we've got the fuses at the moment. Okay, it's raining outside. So I've got my fuse. I'll take out the 13 amp one. When we buy plugs, I always try and buy them with factory fitted 3-amp fuses, because nearly everything we do is going to want a 3-amp fuse. Good. I'll put the plug top back on. It's a kind of nylon, this. It's not like most of the plugs we see here are little more than Bakelite, to be honest. Because I can't find any to show you. That's really impressive. Right, we'll plug it in, making sure doubly that we're not plugged into the test kit. Sorry, the mains power supply. We'll unplug that. Right, we'll get the meter ready. Got the bottom in the dishwasher. The meter. That's an avalanche of stuff. What's in this box which is always avalanching? Oh, it's a JWRM2 that I bought on eBay. It keeps finding its way to the floor. It got brought in here because I've got no customers' jobs, and then customers' jobs came, so it never got looked at. They're awful sets, you know. Anyway, that's why I bought it. So, if I remember rightly, our outputs are here. So plug the radio in, it's on, and we've powered up. Let's look at what voltage we've got. At the moment we've got 12.4. I think it'd be easier if we use a negative onto that. Right, get the mic plug back in. Did I say that right? No. So I would guess if we transmit, we're probably doing about 3.2 watts at that voltage, which is inadequate. Oh, we're plugged in for deviation, aren't we? I'll do the... Forgotten what I'd planned. Right, I'll do the deviation. Wow. It's about 1.8, so we'll pop that up. We'll go back to the Marconi test set. And we'll see what it says. Wallow. I'll just knock it down a fraction because I think this is reading right. Wallow. Right. So was 1.8, it's now 2.2 to 2.5. That's 4 plus 4, 100 microfarad at 25 volts, 3300 PSU can cap, RS 744 1253. Okay, back to where we were with power. So once it's on high power, it's doing about 3.8 watts actually. So what we're going to do is I'm going to turn the power supply to 13.8, which is where it's supposed to be. And we'll look at power again and adjust it from there. So there we are, 12.3. Let's try it at 13.5. Okay, so I'll tell you what, we'll turn it down to 13.2 so the whole thing runs cooler. And then we'll adjust the power, the transmitter from there. 13.2. Let's see what it drops to on transmit. 13. Right, what power we got now? 14.4. I'll put the meter away. So we're going to just redo this entirely, these three. So checking we've got peak, we have. Checking we've got peak, which I've never altered, yep, that's still correct. Checking we've got peak, which we have. So we've got about 4.7 watts. Never leave it like that, it will kill the transmitter, apart from being illegal. It doesn't get you any better range anyway. So we want that to be 4.4 volts. And we want this now to be 4. Manual says 3.8, but we're allowed 4, so we're having 4. So we're now at bang on 4 watts. Channel 1 is bang on 4 watts. Channel 40 is bang on 4 watts. So that's balanced properly. And as I said, when I've got running it on the power supply, we've got lead loss. But in a mobile set, you're always going to have lead loss, so we set it up like that. Okay, so we want the meter on the front to say 4 watts. Which it does. And we'll just check low power. We never set that, did we? Yes, we did. But it's now not the same as it was. 400 milliwatts. That was flawed because I went and did it on channel 40. There we go. So we're done. Excellent. Back to full power. Might just have to knock that down a fraction. That'll soon drop. It's now settled about 4.05, but I'm sure the detective van's not going to be around for that. Good. Well, that's a lovely set. Don't know what the current consumption is though. All we can do. No, I don't want to do. I'm not going to. I'm being silly if I start messing like that. Right, we'll start putting it must reorder those. Put a couple of these loosely in the top. We don't want to make it tight until we've got all the screws in, so then it finds its correct position. I'll turn it off for now. Unplug the mic so I'm not wandering around the bench with it. So the next set we're going to look at for Mr. Trucking and Farming, we're going to have a second look. I didn't publish the part 1 to the Realistic 3000 base station, and I erased the footage because I thought we'd done with that memory card, but we hadn't. So I'll see whether we can fix the transmitted racket fault. We know we've got a faulty output transistor. And the only one I got turned out to be fake. So we've had one come. And hopefully when I put these screws in, the dishwasher will be sufficiently done for me to recover the base plate. So I say there's no difference between this, the York 869, and the Midland 76900 base station. Just price and features and quality of finish. So when you pay £369 for your Midland 76900, it is this, but it's a Swisher case, and you have to decide whether you think that Swisher case was worth the extra £200. And of course the answer is yes, because I couldn't even make that case for that. So there we go. Cleaned better than it was from the factory. There we are. I'll go and get the lid. Well, another 20 minutes has elapsed. It's so clean you don't know which side is which now it's out of the dishwasher. It'll of course put all its dirt on Mr. Chippy's dinner plate. Right, they should be the remaining screws. I don't know whether I've ever said to you, there's no hot water in my kitchen. We have 2 bathrooms and an ensuite toilet and wash basin in the property. And we had an earthquake some years ago, and the epicentre was Market Raisin. And it knocked out the hot water for it's all electric here, so it's on an immersion heater and a hot water cylinder in the traditional way, and it knocked out the hot water to that kitchen and the main bathroom. And so the fact we have an electric shower in the main bathroom as well as the bath, it doesn't matter. And I tried to claim on insurance, and the insurance said it was an act of God, so I thought, well, stuff that. I'm not in any position to be forking out for replacing it. So I've got a dishwasher anyway, and it's sensible because I'm all electric. It's cheaper to run, it uses less water, So there you go. And I look at these things. My house hasn't had any hot water for the last so many days, and what's the council going to do about it? Well, there you go. That was probably 20 years ago, and can you see how bothered I look? Oh, really bothered. Perhaps you're supposed to fight these insurance companies. I don't know. I don't. If somebody says no, I'd take it as no. Oh, go on. Right, so we'll unplug that. And we'll plug in the roof aerial. The Atron 99. I'm not sure how we're going to tilt this up, because if I put this down, it's going to crush the lead. I'm going to have to somehow kind of hold it, I think, like that. How about that? Are we still plugged in? Yes. It's pull on. Are we half in CB and half in PA? No, we're half in channel 9. That wants a bit of use. I don't want to put switch cleaner in it because there's self-wiping contacts. I don't want to chase the lubricant out. One and a Roger. They'll all be Nottingham 1 burners. Notice they're all off frequency because you're all using illegal radios. Right, well there we go. That's a splendid set, and we'll do an on-the-air test later for it. Thank you for watching the Harrier CB-HQ from 1981.